Okay, so if you're watching this video, it is probably because you are in a unit in trigonometry in your math class, and you started um, converting degree measures into radians. And so, just from that piece of information, we should know that a radian is some way of measuring an angle. Okay, well, also, it should be kind of evident that a radian has something to do with a radius. We know what a radius is. Here's a circle with a radius drawn in. Now, to explain what a radian is, first thing I want to do is I want to say, well, let's pretend we take a string and we put one end of the string at the center of the circle, and we then stretch the string to equal the length of the radius, and we cut the string. So basically, we cut a length of string that is equal to the length of the radius. Okay, well, then we take that string and we lay that string, let me make it a little bit thicker so it shows up better. We make, we, we lay that string on the circle, just like so. Okay, now that is one radius length on the circle. Okay, well, so assuming that is exactly one radius length on the circle, um, well, I'll get that in a second. I'm gonna put a little mark right here. Okay, and now I'm going to, that was convenient. Okay, so there's a second radius length right on the circle there, and then I'll take a third one and put it right here and mark between those two guys. And you notice that it takes, well, let's see, I will do this, and how many of those radius lengths does it take to get all the way around the circle? I must say I did a pretty good job of making this accurate like it really is. So 6 of them make it almost all the way around. I wonder if you know exactly how many of those radius lengths it takes to make it around the circle. Hopefully, you remember learning this formula, the circumference of a circle. How many radius lengths is the circumference of a circle? It's 2 pi of them. Pi, of course, is about 3.14. So to make it halfway around the circle to this point here, it takes exactly pi of those radius lengths to make it halfway around the circle. So now, what is a radian? Let me get to that finally. Well, let's say we draw an angle to right to where the first radius length ended, and we'll call this angle theta. You've probably encountered theta, the Greek letter theta, if you're watching this video. Um, well, theta, this angle theta is exactly 1 radian. 1 radian. It's the angle that intercepts one radius length on the circle. A central angle that intercepts one radius length on the circle. Now, so let's think about how many degrees that is about. Well, it would take a little more than 3 of those radians. It would take exactly pi of them, a little more than 3 of them, to equal 180 degrees. I'll let you digest this. 1 radian is a little less than 60 degrees, somewhere in the upper 50s, maybe 58, 50, anyway. It's almost 60 degrees, but not quite. But we're not interested really in trigonometry in talking about whole numbers of radians. Everything you'll be doing in trigonometry will deal with multiples of pi radians, and I'll create a separate video for that. You'll talk about pi halves radians, or pi thirds radians, or 5 pi sixths radians. Now that also will, your teacher may have given you a copy of one of these things called a unit circle. Throw it away, if you ask me, because all this information you can get without memorizing it. A lot of teachers like to ask you to memorize this stuff, but it's totally not necessary. But see all these things with pi in it? Those are radian measures. Pi that's pi radians. Pi of those radian, pi of these, a little more than 3 of this angle. That's all that means. And I'll create another video to explain some of those conversions. But this is good for now, I think.